Today's video is all about safety, and it really doesn't have a whole lot of 3D printing in it, but any of my friends and family that come into the basement, it does impact them, and as our logo so well describes, it has been a bit of a problem over the years. Hello everyone, Chris here, and yes, today we are going to tackle yet another project. This one is all about safety, like I said before. I've tried to tackle this one a couple of different ways over the years, and I've never been able to get it 100%. But hopefully this time around, we're going to get it as good as we can. And of course, I'm talking about the infamous stairs down to the basement. They're not all that even, so we have to do whatever we can to make it as safe as possible. And today we're going to be tackling the railing. I do have an existing railing on there, but it's not all that effective, and I have come across some rail that would be a lot better in its place. So that's what we're going to do today. So let's go to the top of the stairs, and I'll show you what we're going to do. So here's the staircase down to the basement. You can see my new neon sign. I got that for Christmas. Let me try to get you a better shot of that. There it is. It's pretty awesome. But that's not why we're here. We're here because of this railing. Now, back when I did the garage, I redid it a couple of years ago, I switched this railing up. It actually used to be over on the right-hand side, but I used a 2x6, you know, back when wood was somewhat affordable. I don't really remember why we went with the wider 2x6 over here, but it's not all that convenient to use. And I recently did a project where I had some round railing left over, so I thought it would be good to swap it out and incorporate a little bit of 3D printing here and there. Now let's go to the bottom of the stairs because it's going to be just a little bit easier to get the work done and for you to see it. So let's just go ahead and take this old 2x6 off. We can time-lapse this part. With the old rail down, you can just see it had the standard style rail holders. The rail we're going to put up has some specialized holders, but with a little finesse, I think we can make these existing ones work. And this is what we're going to replace the railing with. It is called Deckorail. I believe it is only available from Home Depot stores. But basically, it's just a PVC sheath around an aluminum rail. Take a little closer look. I believe the exterior of this is around 1.5 inches, but it is a very solid rail after you get it installed. And you can buy all these different fittings. This one you can join two pieces together just by inserting it inside, and then you screw through the bottom. Now the railing we're going to be replacing is almost 12 feet long. So this comes in 8-foot sections, and I'm going to use this little short section there at the bottom to finish it up. And then anywhere there's a gap, they give you a ring. You can just slide that on there so it'll cover up the gap and not interfere with your hand. And I am not an expert at installing this stuff by any means. This stuff is intended to be a secondary rail, but there is one tip that I can give you if you're going to put this stuff up. I said this is just a PVC sheath around this aluminum. The most frustrating part when you're trying to work with this is this sliding in and out of the sheath because the cuts have to be identical. So what I like to do before I even start working with it is drill one pilot hole just to make sure that these are connected. Then I can cut it or do whatever I want with it and it won't constantly slide out. There's a lot of different ways to do it, but one extra pilot hole is probably not going to hurt you any. They recommend a 5/32 bit to use with their hardware. Also a note on their hardware, most of it is self-tapping. It does have a number 2 square head and it really likes to strip out. So maybe try to find a little better grade hardware or just be really careful with the stuff that they give you. There, now that sheath won't move anywhere when we're trying to work with it. I'm going to go ahead and do the same thing to the longer section. So back to the stairs, all I have done is put the top hanger on loosely up there so I can get a measurement where I want to cut this. Again, we're going to have the long section and then a shorter one on the way down, but I like the joint to be on a hanger. They recommend a hanger every 6 feet. We're way closer than that here, so that's no big deal. But I would like that joint to be somewhere in here. So I'll take a measurement, and then we'll cut. For this kind of stuff and aluminum extrusion, I use a twin town blade I got off of Amazon. Works great. Fun King, Glenn actually told me about this. It's a pretty good blade for the money. It'll work great for our railing as well. So I've got our top one secure up there. I'm going to go ahead and do that second one. We can go ahead and back out our screw that we use just for locating, keeping that sheath on. Then we can mount our lower rail. I'm going to go ahead and put our joiner section on because it is much easier over here at the table than it is to drill a hole while it's on the stairwell. Those just slide in. You can drill and shoot some screws in it to keep it in place. Don't forget to put your gap collar on when you get over to the rail. That's pretty aggravating when you get these put together, and this wasn't on there. And we can back out our retaining screw that we put in there earlier. Don't need that anymore. Okay, back to the stairs. And our last section here. Remember, put your gap ring on, and you can just slide this into our first section. It's a good fit, and then we can go ahead and mark for these other two collars and finish up the install. So the handrail has been replaced. It's looking good and it's pretty sturdy. But if you've made it this far in the video, you might be asking yourself, how in the world are we going to integrate 3D printing into this project? Well, as with everything down here, it has to be customized to our liking. That's right, we need some custom end caps for our railing. But what might we put on a custom end cap that we would 3D print in Chris's basement? Here we go again, back into Fusion 360, showing you some software I really don't know how to use. The inside of our rail here is about 26 millimeters, so let's start there. What I'm thinking is we need some sort of insert that's able to press to the outside of the walls just a little bit so it stays put. But let's start with a 26. And then the outside PVC portion of our rail, we want to cover the rough part of that up. And that we're setting at about a 38.7. So let's do that as well. 38.7. So there's pretty much the representation of the rail. Now we can build the parts from here. So from there, let's make the inside of our rail, this piece here, pretty meaty. So let's go with an offset, and let's call that, what's to do, negative 6 millimeters. And let's bring that whole intersection out 30 millimeters. So 30 millimeters into the end of the rail. That should be more than enough to hold it. Now, like I said, I'd like to have some sort of spline out here. So what I'm going to do is I'm going to draw on the top of this. We were at a 26. I want it to be just a little bit bigger so it grips. So let's take it to a 27. From there, I'm going to extend just this 1 millimeter part. So let's extrude it. And we'll bring it down. Let's call it 5 millimeters. And we should be okay to join. From there, on this new lip that we've created, I am going to do a fillet. So we get a nice round surface there, like so. And then I want to cut this whole thing up and make a bunch of spline cuts in here. And the easiest way that I know to do this is I'm just going to draw a rectangle. Let's do a center rectangle. And let's call those 2 mm wide. And I really don't care how long it is. That's good. And I'm going to use that rectangle, let's finish that, to extrude down through this 15 millimeters to cut a nice slot. There we go. Now I'm going to take that and we're going to do a pattern. Circular pattern. And we're going to use these faces. We're going to select our axes. And let's just make a bunch of them. How about a nice odd number? What's 9 look like? We can do better than that. How about 12? Twelve's not bad. How about 14? 15. I like 15. And now we have a bunch of nice cuts. So the idea is this is going to be just a little bit bigger. This slides in, and then these splines are going to let these flex, so it's going to hold against the outside of that rail and hold our cap on. Now we just need to build our cap. So the outside of our cap here shouldn't be that big a deal. Let's make that, we're just going to extrude all of this. Let's make it 3 millimeters. So that's a nice cap, kind of boring. But now, what do we want to put on the outside of this? Hey, I know. How about a benchy? Now, working with a benchy can be pretty tricky. Also, if you read the license, you're really not supposed to be doing this. It's just everyone does it. But there's lots of different facets to a benchy, so it's very complex. So to work with it efficiently as an STL file, you need to shrink it down. And still, my favorite way to do that is in Mesh Mixer. Mesh Mixer has been around forever. It's very old school, but it still works great for a lot of different things. So let's just import our benchy STL file as is. You can see it has 112,000 vertices and 225,000 triangles. That's going to be really hard to work with in a CAD program. So that's why we're here in Mesh Mixer. So we're going to go to Select. We'll click on the model once. We'll go to Modify, Select All, because we want to alter the whole thing. Then we're going to go up to Edit and hit Reduce. I usually just do this by percentage. Once you click on this, it's going to go ahead and try to reconfigure. It's going to count the vertices and triangles again. So depending on the computer you have, might be a stretch. But we don't need a lot of high def here for our benchy end cap. We'll know what it is. So let's go ahead and take him down to 15% and see what it looks like. So it scaled it down a little bit, but probably more than acceptable for us. So let's just accept that. Now we're down to 95,000 vertices, 191,000 triangles. So it's a little better. I think Fusion would be okay with this. If not, we can come back and shrink it even more. But let's go ahead and export, and we'll just do benchy less. And now let's go ahead and try to bring it into Fusion 360. Let's do an insert, insert mesh, benchy less. Here's where it likes to choke, and we'll say OK. Now, I like to get these into position before I try to convert them. Also, we're going to shrink ours a bit, but we'll do that here in a moment. So I'm going to go ahead and move it. And we'll get it roughly into place. I'm good with that. Now I'm going to convert it. So mesh. You can try to put it into a group, generate a face group, all of that. It might make it a little bit easier, but for a lot of the projects I do, it doesn't help at all. So I'm just going to go ahead and hit convert to mesh, and hopefully by reducing it, that helped us out. It's going to give you a warning because it is still very large. Let's go ahead and hit OK. So it thought about it for a minute, but it did go ahead and do it. So now I'm going to cut the benchy in half. I'm just going to draw a straight line right through it. And then I'm going to split it. Let me get this other body out of the way so you can see what's going on. Split, benchy, and our line. And after some waiting for the processing, we now have two benchies. So let's take the back half off. Let's bring our body back up. And let's try to line it up here. I'm just going to take a look at it here, and I think we're just going to scale our benchy down. So let's go to modify, and we'll scale it. Let's see what 60% looks like. That's not bad. Let's work with that. And since our benchy is so hard to move around, let's just move our knob piece. That looks like a Chris's basement rail knob to me. And let's combine that. So there we go, we're pretty much done. We just have to figure out how to print this thing. Now, normally I would put like a chamfer back here so that we could print it from this direction and we wouldn't have to use supports. But to get it to fit flush on that rail, I really don't see a way around it. With the way I designed it, supports, they're just going to have to happen. So let's go ahead and make it. We'll go to utilities, make, and then we'll pull it into the slicer. And I know people don't like it when I use supports on all of these things, but sometimes you just can't get around it. Even if I stand them up, I'm going to print them with the splines down like this. I want to keep that flat edge like I said before. So let's try our smart supports here, our paint on. We'll do smart fill, and let's tell it that edge. Let's slice it and see what it does. You have to have it on enforcers only. I just don't want any supports in the center. That's going to be way too hard to clean off. So I like that. That's good. And it limits your supports. We don't really care if there's bridging inside there. It can be messy. Doesn't matter any. There are going to be some loose ends in here because those could use some support, but it's going to be too hard to pull that out of there. We'll just clean it up if we need to. It's going to be kind of an interesting finish because this is kind of at a grade because of how we usually print the benchy. But I think I'm ready to let it rip. To the time lapse! Now that's custom. And there it is, our custom benchy stair rail is complete. Hopefully making the lives of our friends and loved ones just a small percentage safer than it was before. Always, watch that second step. That will be it for today. Hopefully you enjoyed this video, and I'll see you really soon on the next one.